All right, welcome back to part B of network security concepts. So in this one, we'll continue on with common network attacks, IP vulnerabilities, and TCP UDP vulnerabilities. Again, hope you have a coffee because it's a long one. So common attacks. So we talked about malware and that in the last part A, and this one will look at the types of attacks in reconnaissance, access, and denial of service attacks. So these are very common types of attacks launched against networks all the time. So we'll be having a look at that. Again, embedded video to save me talking. And these ones are a little bit shorter as they go through each individual little thing. And I'll hand it over to the voice in the box.
It's time to get real. We're going to jump into common network attacks. And with common network attacks, we're going to focus on three, which is technically really four, which we'll see. But what it comes down to is they're here regarding threat actors. So let's kick it off. We've got our three common network attacks that exist. Number one being the reconnaissance or the recon attack. And this is all about gathering information and learning about vulnerabilities that exist in the system. So from there, we can target those vulnerabilities in what's known as the access attacks. With an access attack, you're trying to take advantage of those vulnerabilities or weaknesses, and they could be in things like authentication or file transfer protocol, web services running on port 80, port 443. Even SSH has been known to have these vulnerabilities, and Cisco released SSH version 2 on a lot of their iOS boxes. DDoS attacks, though, denial of service. Having a multi-million-dollar business is great, as long as people, which are the users and customers, can reach your network services and reach the web server, be able to transfer their money, make purchases, and literally be able to use your environment. Denial of service is all about having a disruption of network services. So let's jump in deep on these. We're going to go ahead and get into recon attacks first. And there's many different types of reconnaissance attacks that could occur. But what we really start with is like a storyline. We're going to have a threat actor perform some type of query of a target. And for that, it could be something as simple as a who is. So we can start by me going to research.domaintools.com, up there in my URL. And I'm going to just go to cisco.com as my who is lookup. I'm going to get more depth information on cisco.com. If I scroll down to the bottom here, we're going to be able to see that I get this whole who is record. The domain name is cisco.com, the registry domain. I get dates and times. I even get information regarding location and phone numbers and even their email address. This gives me a huge amount of information regarding the company. And there's actually ways that I can get more information than this. So this would be my initial level one beginning step of reconnaissance for the company of Cisco.com. Now, continuing onwards, though, we can do something like a ping sweep of a targeted network. And there's tools that are readily available for things like a ping sweep. One of them being right here is, for example. And there's a tool that you could use. And I just did a ping sweep on a local network, but I also went further than that. I did a port scan. And I pulled back multiple devices that were live and responded on the network with a ping sweep, along with different ports that are currently open on those devices. From there, I can research these ports and services and try to see if any vulnerabilities exist. With that idea in mind, I can use vulnerability scanners to actually target them at those live IP addresses and see what comes back regarding applications, operating systems, service packs that all exist. And finally, we can actually start running exploitation tools to take advantage of those vulnerabilities.
Okay, so you can see there that reconnaissance is very effective in gaining information so that you can plan further activities against the network. And you saw there quite easily how it is to gather information from various sources to give you more and more concise information that you can then go on and gather even more on. So via these little steps. You saw that they quickly built on each other. And you can see in this slide, there's very many examples there for the various tools available. Like he used Angry IP Scanner, which is just one of the tools, and it did the ping sweep and the port scan all in the one tool. Now there's others that, we saw earlier, Nessus and others. So it's very easy to get your hands on these tools and start attacking based on these reconnaissance activities. So the next one is our social engineering, and after this one plays through, I'll give you a couple of live examples that I've experienced over the years.
So it's time to move on to access attacks. With access attacks, you've already gained your information, you've already done your recon, but now you're here to hit them. You're here to hit the box and have attacks that take place to manipulate data or even corrupt data or information. There's a lot that can come into play here. One of the first things we can talk about would be things like password attacks. In this tool, for example, known as THC Hydra, amazingly powerful tool for brute force password attacks. It can target many different services, for example, Telnet, FTP, HTTP, IMAP for email, POP3 email, Cisco authentication, Cisco enabled passwords. You name it, this tool is great for pen testing. And that's what it should really be used for, is penetration testing on a legal standpoint. So we've got password attack tools. We've got tools for spoofing. You can pretend to be anybody you want regarding MAC addresses using MAC address spoofing tools, as long as even pretending to be a DHCP server. We can exploit connections by using trust exploitations. We can redirect traffic to other targets. We use man in the middle beautifully, just via spoofing some MAC addresses and using DHCP. And of course, we can overwhelm targets and try to get data out of them by using buffer overflow attacks. There's so many different things out there. Social engineering is kind of like made this number 4, kind of just like slides in there. But social engineering allows us to take advantage of the human nature of individuals. Whether we're talking about pretexting, trying to confirm the identity of somebody by asking them, is this, Mark Jones? Oh, it is? Great. Now I've just learned that Mark Jones is at the phone number that I just called. We use things like phishing to disguise ourselves as being someone else. Also, we can do things such as spam, where we send garbage email to the hopes of getting someone to click. And if they click, we can then try to take advantage of them. One of the common things we talk about would be tailgating, where we have secure physical doors. And you walk in, being a threat actor, holding a cake in one hand and balloons in the other. You really think someone's going to slam the door in your face and say, well, you got to take out your ID card and scan to get in? Or do you think you're going to hold the door open for you? That's the idea of tailgating, having a threat actor quickly follow through. Impersonation can be done as a physical individual, but also even in the terms of the internet. So we did our first query regarding Cisco, and we got to see some info about Cisco and the domains that they own. Well, what if we wanted to create an email and pretend to be Cisco HR? Well, I can go to Google Domains here, and I could actually say, let's see what's available with the name of Cisco. And for the cost of about $12 a year, I believe, there we go, $12 a year, I can purchase ciscosystems.business. And then I can make an email. And this would be completely illegal and horrible. And the email would say, it's time to update your payroll. We need to reconfirm all direct deposit accounts. And I can literally have them click on a link. And the link would be ciscosystems.business. Instead of .com, it would be .business. And it would look really legit. And I would do my best to be social engineer extraordinaire. I would steal some email signatures to make it look even more professional. Have a picture of myself down at the bottom, like, hey, happy, this is your HR person. So please click on this link, go to ciscosystems.business and upgrade your direct deposit information. And then the evil threat actor that you are would steal all those routing and account numbers and literally have their way with accounts. But that's the idea here when we talk about things like impersonation and social engineering. Can you get someone to trust in you? Can you get someone to click? Can you get them to believe in you using human nature?
All right, so with that, I have worked in a firm and experienced the old tailgating activity. People, if you dress professionally and look like you're meant to be there, you can quite often just walk straight into a business and then, walk around, gather information about where laptops are stored, make it so that emergency exit doors are available from the outside, that sort of thing. And that's what occurred to this business. We had a couple of people just walk by reception. I mean, we had over 2,000 staff members working in this office, so our receptionists certainly did not know them all by face and name. So they are appropriately dressed, and we just had them walk through into the business. And it was another staff member that actually felt that they were doing something abnormal, and she noticed that they seemed to have done something to one of the emergency doors, and after they moved on, she checked and saw that they'd taped over the latch. So it was only the weight of the door holding it closed. It could easily be opened from the outside after hours. So that's a live experience of tailgating from my personal experience. So access attacks can take form not just in electronic, but in physical form as well. Remember, assets are anything of value for the organisation. This includes the facilities, the people, as well as the systems and data. So be aware of that. Now, we went through, we've done password attacks, spoofing attacks, all within that video, so I'm not going to spend any more time. Now, another one on this social engineering is you get so many cold calls asking you to prove your identity before they'll actually talk to you about something. So what are you asked to provide? Your full name and your date of birth. You know, you've just handed that over to who knows who on the other end of the phone. Are they legitimate? You don't know. All right, so on an example here, we had somebody call looking for a former employee who happened to be the daughter of one of our other staff members. So the call was put through to them, and he went, give me your department and name, and if I can contact you legitimately through the organisation, I'll talk to you about the location of that individual. So this individual was actually a police officer, and she gave him her name and department and said, ring any police station and they'll transfer you through to me, not a problem. So he did that, and she said it was the first time somebody challenged her on the phone. In all the years as a police officer, that's the first time somebody challenged her legitimacy as a police officer over the phone. So it's just natural human nature to provide a level of trust to authority figures that we've grown up being taught that we need to comply with. I think he went through and gave these attack vectors a very good description. So here we are into some other information. So protect yourself against social engineering attacks by not doing certain activities that we really do by nature. So don't give out your username, password, credentials. Everybody should know that one by now. Report suspicious individuals. this is what actually caught those two individuals that were setting up the facilities for a future break-in. Okay, we actually got them on CCTV footage and what they were doing. We were able to get clear images for the police out of that, and we left it to the police after that. But we went around and double-checked all of our security where they had been and found a few other items tampered with that would have enabled them to do what they wanted to do after hours. So always make sure your systems are locked. Okay, how many times have you seen people walk away from their computers and leave them open so they don't lock them, so you don't have to provide credentials? You can just sit down in front of the keyboard and have access. Don't reuse your passwords. Right? Big one here, and it's a big failure of so many people now, is they give their own personal information out to social media sites. Your name, your address, your date of birth, your phone numbers. It's all out there, and once it's out there, it can be gathered and used against you. Alright? You can read through the others, but they're the main ones I wanted to give you. So the next one is the various denial of service attacks. Very short video.
What about those threat actors that just want to watch the world burn? Maybe this is part of another escalated attack. Maybe this is part of a big grandiose scheme. Or maybe literally this is a political act of just, we need to take down this target because we don't like what they're doing right now. Well, regardless of the agenda of a threat actor, denial of service or DDoS attack can be rather detrimental. A denial of service attack is an attack that's going to interrupt network services. This can stop users, it can stop devices, even crash applications from being able to function. Now, there's two ways it usually goes about this. There's an overwhelming amount of traffic, which means an enormous amount of data at a high speed rate is hitting a target, whether that target is a user or it's a server or it's even a network intermediate device. That target's unable to handle that amount of data, so then it cannot respond to legitimate requests from legitimate users. Besides just an overwhelming amount of data hitting a target, a denial of service could also be where maliciously formatted packets are being created and are being sent at a target, and that target doesn't know how to handle that message. Because it doesn't know how to handle the message, it causes an error condition, and then that targeted device cannot, again, respond to legitimate requests. Now, we can change this denial of service attack to be a little bit different, and that's called a DDoS, which is a distributed denial of service. And this is where we have multiple sources of threat actors, all hitting a target at the same time. The common way this is done is using a botnet or a zombie. And a zombie is going to be an infected host. And this infected host is part of the overall collective that's being used by a threat actor to target a specific device, whether it's a user or a network device or an application. This is commonly seen on places like the dark web, where we can talk about the ability to rent a botnet full of zombies, and for a specific time, a specific amount of throughput, being able to hit a target.
All right, so as you can see, denial of service can cripple an organization very quickly and can be very easily launched from multiple sources with a distributed attack. Now, just before we go on, let's go back that one. Now, this used to be very, very detrimental to businesses before we had automated systems that could rotate through a IP address through the DNS system. Okay, the DNS domain name system used to be manually updated and could take up to 48 hours for changes to take effect. It was very slow and very cumbersome. Now, systems evolved and you could register now a range of IP addresses so that it would rotate through those IP address pool and change the associated IP address. This helped mitigate these types of attacks in the early days, because when you had these denial of services, it was very slow and painful to actually get those IP addresses changed and updated through all the tables. So it would take a long time to bypass these threats. Nowadays, we can shorten the time that these things are effective against us, but they're still vulnerable, and a lot of organizations do not want to invest the time and resources into mitigating this with large numbers of IP address rotation. It's just one of the ways you can mitigate it. Not the best way, it's just one of the ways. Alright, so moving into the protocols now. So this one we'll be looking at IP and the various subprotocols within IP itself. Taking a little while to load. Here we go.
Let's get in the mindset of a threat actor. And in the mindset of a threat actor, we're going to talk about IPv4 and IPv6 attacks. That's all contained here in IP attacks. Now, IP, or Internet Protocol, does not validate whether the source IP address that's seen in a packet is actually the legit, real source IP address for this message. Because of this, our threat actors can send packets using a spoofed source IP address. They can put whatever source IP they want on the message. Security analysts must understand the different fields that exist in both IPv4 and in our IPv6 headers. So let's dive deeper into IPv4 and IPv6 attacks. And first, let's hit ICMP attacks. We're going to cover this in more detail in just a little bit, but threat actors are going to use our ICMP messages, which are our echo packets for the pings themselves, to discover subnets and hosts on networks. They can also use ICMP attacks to generate denial of service floods. They can even use these things to alter the host routing tables of a targeted device. With amplification and reflection attacks, our threat attackers are going to prevent legitimate users from gaining access to info or to even use network services by using denial of service and distributed denial of service attacks. With spoofing attacks, a threat actor can spoof the source IP on a packet. We mentioned this. We can see this with blind spoofing, or we can see this with non-blind spoofing. To put more insult to injury, an attacker can be part of a man-in-the-middle attack. They will position themselves directly between the source and destination to transparently monitor, to capture, and to even control the communication, which is all network traffic moving between the source and destination. With session hijacking, a threat actor can try to gain access to the physical network and then use a man-in-the-middle attack to not just watch a session, but to actually hijack a session and become the, quote, legitimate user in the conversation. So we dive deeper then into ICMP attacks themselves. And threat actors are going to use ICMP attacks for recon and for scanning. Now, this is commonly used for gathering information. They want to map out the network topology. They want to discover which hosts are actually active and reachable. They can even use these attacks to identify the host operating system known as fingerprinting. You can even see the service packet being used. These ICMP attacks can also determine the state of a firewall and what is able to be reached and reached through. Now, threat actors don't just use discovery with ICMP. They can also use ICMP itself for denial of service attacks and distributed denial of service attacks. And our networks should have strict ICMP ACLs deployed to filter ICMP traffic on the network edge and throughout the network topology where it should not be allowed. Now, ICMP attacks themselves have a variety of different, let's say, uses, but commonly it's going to be for host verification as well as denial of service. And that's usually the ICMP echo request and the echo reply, which is the standard echo messages you have with a ping message. With ICMP unreachable messages, we can use these to perform network recon and scanning attacks. With masked reply, we can try to map an internal IP network. With the redirect, we try to lure a targeted device into sending all of its traffic through a compromised device that then utilizes a man-in-the-middle attack. And with router discovery, we try to inject bogus route entries into the actual routing table of a targeted host. Just imagine the outgoing possibilities of a targeted host having bogus route entries inside of it. Now, we'd like to talk about what's the real use and tools, and here is one of them, low orbit ion cannon. This is an older tool that's still been useful. There's a variety of flavors of it now. We have X over IC, high orbit ion cannon, and there's even some more advanced tools like Hulk, but that goes more to the application layer and not so much here at layer 3. Or with tools such as low orbit ion cannon, they even allow you to connect your client to an IRC server and remotely control your low orbit ion cannon client. Pretty much this is installing a voluntary botnet you're able to then utilize with zombies to do low orbit ion cannon. Now, we're not endorsing this tool. This is only for ethical and legal purposes for use. Perfect.
All right. So as you can see, even protocols that we use on a daily basis have vulnerabilities built into them, because these protocols have been around for decades and security wasn't the focus when they were designed. Functionality was. And back in the day, society as a general rule was more honest than what it is today. People would not be able to do what they do today, because you can see the tools have enabled very large numbers of people to take adverse actions against these devices, which wouldn't have been able for them to do it previously. So just be aware of that. So again, make sure you secure your network against traffic. Now, this is both legitimate and so what we want to do is look at where legitimate traffic sources will be and put filters, which are access control lists, in place so that we can control where that information is originating from and where it can go, and what parts of the protocols we want to be able to be used. Each protocol has a different function. Because it has a different function, it has a different port number, and we can filter it based on those functions. Okay, so we can definitely enable higher levels of filtering to mitigate these attacks for ICMP. Next one is our amplification, reflection, and spoofing attacks. And this one's 3 minutes long. Over to the voice in the box.
To jump into amplification and reflection attacks, and with amplification and reflection attacks, this is really a combined attack procedure. Our threat actors are going to use amplification and reflection both to create a denial of service. With amplification, the threat actor is going to forward an ICMP echo request message to many hosts in number. These messages that we forward to these hosts, all these messages are going to contain a spoofed source IP address. And that source IP address is of the victim we want to hit. So when we message all of these machines, all these messages have a spoofed source IP of the actual target that we want to hit with our traffic. Now, the reflection is the second half of this attack, where all those hosts we message respond back to the source. That source being the poor victim with the spoofed IP address that we put in our message that we sent. So what it looks like is this. Amplification goes out. Our message could be a multicast or a broadcast to a targeted group of machines. That message includes the spoofed source IP address. The reflection, all those targeted users that we hit, are responding back with the source IP of themselves, but now the destination IP of the spoofed address that we had originated. And that poor victim, which had nothing to do with this traffic whatsoever, is being hit using that reflection. A good example of this would be using even a tool known as Smurf6, which is built and ran using Python. And using Python, you can even see here inside of the code, microseconds with the I modifier, interface victim IP, the multicast network address. We can actually see live Python code being used in a variety of our network attacks nowadays. Lastly, we have address spoofing attacks themselves. This is where we commonly can see non-blind and blind spoofing. And blind spoofing is the easiest to talk about because this is where a threat actor can't see the traffic being sent between a host device and the target. And in blind spoofing, we have our threat actor here trying to manipulate and utilize MAC addresses for their own DOS purposes. With non-blind spoofing, this is where we actually have a threat actor trying to hijack a session. They're inspecting the reply packet from a targeted victim. They try to determine the state of the firewall and the sequence number being utilized at that moment, and they try to literally take over and become a client using unethical means. Now, what it comes down to here regarding our threat actor is they're connected to a switch on port 2. They see the MAC address of the server that's existing on port 1. The switch right now understands that the server resides on port 1. But if the threat actor spoofs the MAC address of the server and attempts to become the server, and then they communicate to the switch will learn now that the MAC address AABBCC, which was the server MAC address, that MAC address is now inbound. It's coming in on the ingress of port 2. Thus, for the switch says, oh, I understand that AABBCC, that machine has moved and now exists off of port 2. So whenever I, the switch, must send traffic to the server, of course, I will send it out now on port 2. So we have our users, which can be legitimate. We have our threat actors, which can do unethical things, all using the same network devices and network infrastructure that our normal everyday traffic runs on.
And as you can see, these types of attacks can quickly overrun a system very quickly and easily by this simple use of protocols within the network. By making use of these vulnerabilities within the protocols, these protocols are built into IP. They're always there. So knowing how our protocols work and what they can do will help you protect your network from these vulnerabilities. Next, we'll move into the TCP UDP. So this is layer 4 vulnerabilities. And remember, our header is made up of various segments or fields, and one of these areas is control bits. Now, within the control bit field, we have 6 bits, and these will tell you whether the packet is urgent, whether it's an acknowledgement, whether it's pushing, resetting the connection, synchronizing sequence numbers, or finishing off the communication. So these can be used to disable or change the communication. Remember, TCP is our built-in reliable protocol. So it is the one that has to be acknowledged. It has to have a sequence of handshakes for it to establish. So what we can do is adjust these fields and make it like it's middle of a conversation, and the receiver will wait because it's going to go, oh, I'm missing some parts of this message. It's arrived out of sequence, so I'll just put it in a buffer and start to wait for the rest of it. That's one of the things you can do with this protocol. for attacking. So reliability delivery means that we need to acknowledge receipt, and if we don't have that acknowledgement, we can have substantial delays and we can have multiple retransmissions, causing an overload of bandwidth being used. Flow control enables us to adjust the amount of traffic being sent at once before we get the acknowledgement back. And we've got stateful communication. In other words, we need to make sure that the parties involved in the communication agree with each other. So this is the three-way handshake, if you pass your minders back, where we communicate with the destination, they acknowledge that, and they start their end of the communications, and we acknowledge that. So it's a handshake going, yes, we're going to have a conversation, these are the parameters used, and then let's start. So knowing how these protocols work, I've said it before, enables us to understand the vulnerabilities that can be used to attack us using these protocols. With that knowledge, we can start to mitigate these attacks. So next up is a refresher on our connection being established, our three-way handshake. So we have the initial opening, which basically says, I want to request a session, and what it's doing is sending a sequence. Now in the sequence field, it will have a value, which is how it's going to keep track of what portion of the conversation has been sent. And in the control, it'll say synchronizing. So it's basically asking for communication to start to be established. The destination will send its own synchronization to start its conversation, as well as acknowledge the receipt of the synchronization from the originator. So here we have client B, sequence 300. It's acknowledging, saying the next part of the conversation I expect to be part number 101. And in the control, it's sending synchronization and acknowledgement. That's received, and the original A will now acknowledge the sequence from B. So it's the next sequence number, it's 101. It's acknowledging that it received 300, and the next part of the conversation will be 301. And it's just using this to acknowledge receipt of that synchronization. There's our three-way handshake. Now, what we can do is flood the system with these SYN requests, and in this example, the web server will send synchronization acknowledgements waiting for the three-way handshake to be finalized. So because you're only doing a partial opening, it's tying up resources so that legitimate users cannot gain access, because all of the ports have been used up with these bogus connections, and they've got to time out before legitimate usage can be connected. How does the finishing of the conversation work? So, as you remember, because everybody remembers this one way back when, we have device A send a finish or fin. It's received. B will send back an acknowledgement saying it received the request to finish the conversation. It'll send its own request to finish the conversation, and it'll expect an acknowledgement coming back. So that is a clean ending of the conversation by both parties. So we can hijack those systems by resetting the connection, by not doing or not completing the handshake sequence, and this ties up the resources of the devices. UDP doesn't have as many fields, but it's very simple and can be used in different ways. Okay, it doesn't have the handshake, so that's not a vulnerability that can be exploited with under UDP, for example. But it can be exploited. So using low orbit ion cannon and other tools, we can flood UDP packets from a spoofed host to a server or a subnet, and then overrun those systems. Then we would get port unreachable messages being returned, and we would generate a lot of traffic clogging up the network, making it unusable or unresponsive. That brings us to the conclusion of part B. So I'll see you in the next one. Please recharge your coffees or whatever your drink of choice is, and I'll see you in part C. Bye for now.